A damp Cotswolds morning, a man in a grease-streaked sweater kneels over a battered machine in a tiny coach house workshop. Sacks of parts, tape, noise, the smell of motor oil. He tightens a screw, flicks a switch, and watches the cyclone spin, dirt separate, suction hold. That man is James Dyson. That machine is one more attempt in a relentless series of experiments. It looks simple: glass, plastic, an ingenious cone of air. But the story behind it is complicated. Thousands of prototypes, rejections from industry titans, a pink vacuum sold in Japan for the price of a luxury item, and then, eventually, revolution. This is not just the story of a vacuum cleaner. It's a story about obsession, design, grit, and the cost of refusing to accept that that's how things are done. It's about a man who refused to throw away a failure, and in the process, taught the world how to reimagine an everyday object. What if the thing everyone accepted as inevitable, the bagged vacuum, was simply a design habit waiting to be broken? James Dyson was not born into a factory. He grew up curious, the kind of kid who loved how things worked. Early life, tinkering, an eye for mechanical simplicity, and intolerance for poor design. Those traits didn't appear overnight. They were forged in small frustrations. A toy that broke, a tool that didn't quite fit. In the 1970s, before vacuums became the obsession, Dyson produced a simple but brilliant reinvention of a garden tool, the Ballbarrow. A wheel shaped like a ball meant easier movement over soft ground. It wasn't a tech triumph. It was a clue to a thinking pattern: reduce friction, rethink assumptions, and make the user's life easier. That pattern matured into curiosity about airflow and separation. Dyson was building industrial cyclones for his paint plant when he noticed the same physics could be used for cleaning air. The familiar household vacuum, with its paper bag, lost suction as the bag clogged. What if you separated dirt without a bag? From that question came obsession. Talent starts with curiosity. Greatness starts when curiosity refuses to quit. Dyson took apart a vacuum. He examined bag filters, measured pressure drops, modeled airflow. He borrowed cyclone separators from sawmills and factories, scaled them down, and tested them on dust. He built prototype after prototype. Hundreds at first, then thousands. The famous number circulates in design lore: 5,127 prototypes before arriving at a working, marketable dual cyclone vacuum. It's a staggering number, a measurement of refusal to accept close enough. Each prototype taught something: a seal that leaked, a plastic mold that cracked, a swirl pattern that collected too much lint. Failures did not feel like setbacks to Dyson. They were calibration points. His workshop became a lab of iteration. Tune the cone, tweak the throat, swap motor placement, change plastics, rearrange cyclones. This stage is crucial to understanding Dyson's creative ethos. Iterate until the physics and manufacturing match the promise. That ethos would become as important to his company as the inventions themselves. One prototype proves nothing. 5,000 tells a designer where the truth lies. The prototype worked in the coach house, but the industry rejected it. Major manufacturers told Dyson that consumers needed disposable bags, and that replacement bag revenues were part of the business model. The companies that sold vacuums profited from consumables. A bagless vacuum threatened decades of recurring revenue. So Dyson did what makers often do. He looked for markets that would see his product for what it was: performance, not replacement revenue. In the mid-1980s, he licensed his design to a Japanese manufacturer. The resulting machine, the G-Force, was produced in striking colors, famously pale pink in some versions, and sold as a premium catalog item in Japan. It was expensive, niche, and brilliant. The Japanese launch validated the idea. The cyclone approach worked, and consumers would pay for performance. The G-Force's modest commercial success in Japan gave Dyson something crucial: cash, credibility, and momentum. From mail-order catalogs to trade shows, the G-Force made the world look again at what a vacuum could be. When your home market shuts its door, a distant market might swing open a window. With proof that the technology could sell, James Dyson faced new choices. He could continue to license, or he could control the entire product, design, manufacture, branding. He chose the latter. Dyson set up production and refined the manufacturing chain. The company that would carry his name, Dyson Limited, was incorporated in the early 1990s, and the first consumer models under his brand rolled off UK lines in the early 90s. The radical step, moving from inventor licensor to manufacturer brand, changed everything. Controlling manufacturing meant greater margins, but it also demanded scale, logistics, quality control, and distribution networks. Dyson's stubbornness in design had to be matched by competence in operations. He built a factory, managed suppliers, tackled patent filings, and prepared a brand that would stand for performance and design. Inventors make ideas, founders make systems, and systems are how ideas reach millions. Having a superior product is one thing, protecting it is another. Dyson learned that a great invention invites plagiarism and legal battles. Competitors copied the Cyclone idea. Big manufacturers used cheaper imitations or redesigned around the core mechanism to avoid patent infringement. Dyson fought back in court. He invested time and money in legal protection, patent families, international filings, and courtroom battles. One high-profile example was the legal dispute with Hoover and others that culminated in patent enforcement suits. Those wins had two effects. They established Dyson's claims legally, and they signaled to the market that this was a serious technology, not a passing fad. Patents turned the messy garage tinkering into intellectual property that could be defended and monetized. In the marketplace of ideas, the lawsuit often writes the margin. At first, production under the Dyson name happened in the UK. The ethos was patriotic. Design in Britain, manufacture in Britain. But economics bite. By the early 2000s, Dyson made a controversial choice: move significant production overseas, notably to Malaysia, to cut cost and scale globally. The decision was painful. It meant job losses at home and political fallout, but it also unlocked global competitiveness. The shift allowed Dyson to price more competitively while investing heavily in R&D back in Britain. This trade-off, local pride versus global scale, is the kind of executive decision that often separates niche brilliance from mass market success. Dyson's choice was pragmatic. To keep inventing, he needed margins and scale. The place you design something is not always the place you afford to make it. Dyson's dual cyclone narrative doesn't end with vacuums. Once the company had a manufacturing platform and a cash flow, it invested in invention as a corporate discipline, from the air multiplier, bladeless fan, to the airblade hand dryer and later the supersonic hairdryer. Dyson built a company that applied fluid dynamics and motor design to everyday air problems. These products were often unexpected. They turned old categories into premium design-led markets. Dyson's investment in motors, materials, and new production techniques created a flywheel. R&D produced high-margin devices, which funded more R&D. The company marketed not as an appliance firm, but as a technology company with industrial design credentials. Once you treat household problems like engineering challenges, the product categories themselves change. What turned James Dyson's obsession into a global advantage was culture. He institutionalized iteration, labs, test rigs, modeling teams, and patience. The company pumped millions into research. In recent decades, Dyson has been among the largest corporate investors in applied engineering in the UK. R&D was no longer an afterthought, it was the operating system. Design reviews, crash tests, acoustic engineering, and materials labs allowed Dyson to iterate faster and better than competitors. Employees were recruited for engineering curiosity and problem solving. The result was a pipeline of seemingly improbable products: air purifiers, bladeless heaters, cordless robots. This culture also came with costs: radical R&D budgets, long time to market, and occasional costly failures. But the payoff was brand equity. A Dyson product signaled innovation and quality, premium characteristics that consumers were willing to pay for. A product's price reflects not only its parts, but the thought that built them. How do you convince a consumer to buy a vacuum for several $100s when competitors sell cheaper machines? Dyson did two things. 1. Make the invisible visible. Demonstrations showed dust separating from air. Explainer videos, showroom demos, and persuasive packaging made a functional benefit feel tangible. 2. Brand as technology. Dyson marketed itself like a tech company: industrial design, patents, and engineering narrative, rather than a commodity appliance brand. This repositioning allowed Dyson to command premium prices. The brand became aspirational, a statement about taste and values: clean design, performance, engineering purity. If you can change how people see a problem, you can remake the market for the solution. By the 2000s and 2010s, Dyson was a global brand. Flagship stores, design awards, and millions of products sold. James Dyson was knighted for services to industrial design and innovation. But with success came scrutiny: premium prices during times of economic pressure, patent disputes, and questions about localization, how to adapt products to small urban apartments versus big American living rooms. Dyson navigated expansion through careful product portfolio moves: cordless vacuums for mature markets, compact air purifiers for Asia. The company also expanded into adjacent domains: robotics, electric cars, a high-profile project that was later shelved, and advanced motors, signaling ambition beyond household appliances. Expansion exposes assumptions. A product that works in one culture must be reproven in another. Dyson's path wasn't smooth. Some high-profile decisions raised eyebrows. Offshoring manufacturing angered British critics and unions. The electric car program, announced with great fanfare, consumed R&D capacity and was ultimately cancelled in 2019, costing hundreds of millions and prompting questions about focus. Workforce reductions and restructuring in the 2020s reflected tougher competition and margin pressure. These setbacks are part of a bigger truth. Innovation is risky, and even a design-built empire must constantly reassess which bets to place. Ambition without focus is expensive. Focus without ambition is quiet. James Dyson's story is not only about products, but about an ecosystem. He established the James Dyson Foundation, invests in engineering education, funds universities, and promotes a culture of making. The company's intellectual property portfolio is massive. Patents defend its inventions and provide leverage not only to win in courts, but to attract talent and partners. Dyson's legacy will be measured in steel and plastic, but also in the engineers trained, the patents filed, and the way a household object was elevated into a field of design practice. A founder's real inheritance is the people who learn to think like him after he's gone. 1. Iteration beats inspiration. Thousands of prototypes reveal reality. 2. Design can create markets. Rethink the problem, and the market may follow. 3. Protect what you invent. Patents, legal strategy, and enforcement matter. 4. Scale requires hard choices. Manufacture where it makes sense. Preserve R&D where it matters. 5. Brand is architecture and storytelling. Turn functionality into identity. 6. Ambition must meet focus. Diversify wisely. Bold projects can distract. Innovation is not a single bolt of lightning, but the weather system that follows, and it requires both imagination and the stubborn work of many rainy days. James Dyson turned the mundane into myth. He built a brand where engineers flirt with design and consumers pay for polished physics. Yet the world is changing. Faster product cycles, copycat competitors, geopolitical production pressures, and sustainability concerns. So we leave you with this open question, one that hangs like the final spin of a cyclone inside a clear bin. If design and engineering can remake markets, can a single company keep reinventing itself fast enough to stay ahead? Or will the next revolution come from an entirely new set of assumptions? If you enjoyed this story, subscribe to Boardroom Biz for more real lessons from inside the boardroom.